Let's first explore, once we get glucose inside the cell, if we do not need to make ATP, the process of producing and synthesizing glycogen. Just as a reminder, glycogen is stored in our liver and muscle. It's a primary energy source for storage of glucose specifically, which can bond and create the alpha-1,6 branches, as well as the linear alpha-1,4 bonds. So again, the structure of glycogen is amylopectin, where you have both the linear chain as well as branching. This allows us to maximize the storage of glycogen in our liver and our muscle. So in that last video, we talked about insulin binding with the receptor and allowing GLUT4 to translocate to accept glucose into the cell. Now we've identified that the cell does not need energy because we've converted it to glucose 6-phosphate. Now this enzyme here is actually called hexokinase in the muscle and glucokinase in the liver. And what we're going to do here is we are going to actually then take glucose 6-phosphate to glucose 1-phosphate. So you can see that all we've done is we've switched where the phosphate group is on the carbon ring structure. So now that phosphate group is on carbon 1. So this is called glucose 1-phosphate. Once we have glucose 1-phosphate, we then make UDP glucose. And UDP glucose attaches to a glycogen primer, and we can start making actual glycogen. So we'll continue to attach the UDP glucose and get the branching as was shown in that last video. So again, this is going to be turned on when our body does not need any more ATP for that specific cell. And the determining factor here is that glucose 6-phosphate. So once we get to the glucose 6-phosphate, that enzyme is going to determine if we're going to go through glycolysis in that pathway or if we're going to go through glycogen. Again, when we have a high amount of ATP located in the cell, we're going to store this extra glucose as glycogen through these steps.